Picture this. You're standing at the edge of space, where the silent void meets the vibrant dance of cosmic forces. Above you, the sky is not just empty space, but a battlefield of invisible warriors racing at nearly the speed of light. These are not just warriors. They are messengers from the universe, bearing secrets from distant stars and galaxies. What if I told you that right now, as you watch this, billions of these cosmic warriors are passing through you, through the Earth, and they hold the key to unlocking some of the universe's greatest mysteries? Welcome to the mysterious universe of cosmic rays, where we embark on an adventure to decode the universe's secrets particle by particle. Let's start at the beginning. What exactly are cosmic rays? Imagine invisible bullets shooting through space at incredible speeds, each one packed with energy from beyond our world. These aren't the stuff made for science fiction movies. They're real, zooming through the universe, and some even crash right into Earth. But where do they come from? The answer takes us on a journey to the most explosive events in the cosmos: supernovas, black holes, and star collisions. These cosmic disasters fire off particles so powerful they travel across galaxies to reach us. Why should we care? Because these tiny travelers tell us stories about parts of the universe we can only dream of exploring. Imagine standing at the tip of one of the greatest mysteries of the early 20th century, where the air around us buzzes with invisible energy, unseen. This is where our story begins, not in a distant galaxy, but right here on Earth, with the curious mind of one scientist, Victor Hess. In 1912, armed with nothing but a delicate instrument and a balloon, Hess embarked on a daring journey into the sky. As he climbed, something incredible happened. The instrument began to chatter more fervently, sensing the presence of something unseen, something powerful: cosmic rays. But why go through all this trouble? Hess was chasing an invisible force that he believed showered down from the heavens, and as he soared higher, beyond the protective grip of Earth's atmosphere, the mystery deepened. The readings spiked, unveiling a cosmic dance of particles raining down on us, a dance that had been going on unseen, unnoticed, until now. This discovery was not just a moment of achievement for Hess, but a pivotal point for science. It opened our eyes to the vast, energetic universe beyond our planet. Scientists around the world were captivated. They began to wonder, if these particles are bombarding our planet, what else is out there? What messages do these cosmic travelers carry from the depths of space? As we delve into the rich history and profound impact of cosmic rays, we've journeyed through the past to uncover their discovery and the brilliant minds behind it. Now, as we transition from understanding their origins to exploring their journey through the cosmos, it's crucial to keep our insights organized and accessible. Enter Notion, the perfect tool for capturing the essence of our cosmic quest. With Notion, we can seamlessly bridge the gap between the discovery of cosmic rays and their intricate dance through the universe. This digital workspace allows us to curate, compile, and connect all our findings in a beautifully structured format, ensuring that every piece of information is just a click away. As we embark on this next chapter, let Notion be our guide, helping us to chart the cosmic rays' path from their celestial beginnings to their interactions with Earth, in a way that's both simple and captivating. Join us as we use Notion to navigate the vast universe of knowledge, making the complex journey of cosmic rays easy to understand and impossible to forget. With our discoveries neatly aligned, let's navigate smoothly from the historical unraveling of cosmic rays into their mesmerizing journey through the cosmos. Where do they come from? Where are they going? How they seemingly appear out of nowhere. Imagine a single tiny particle born in the fiery heart of a distant star, or perhaps in the thunderous aftermath of a supernova explosion. This isn't just any particle, it's what we call a cosmic ray, a fragment of energy that embarks on an epic journey across the vast expanse of space. Picture this particle as a heroic explorer navigating the cosmic seas, skillfully dodging planets, stars, and entire galaxies. Its mission is deep, yet straightforward: to travel across millions, sometimes even billions of years, all with a single destination in mind: our very own planet Earth. As these cosmic voyagers make their grand entrance into our atmosphere, they undergo a remarkable transformation. They collide with the molecules in our atmosphere, creating a shower of secondary particles that rain down upon the Earth. This invisible shower floods everything, unseen yet universal, silently impacting our world in ways we are just beginning to understand. Some of these particles even reach the ground, passing through buildings, trees, and even us, leaving no trace, yet connecting us directly to the farthest corners of the universe. They pass Earth, leaving their mark in various ways, from sparking reactions that contribute to cloud formation to being vital in the mutations that drive evolution. Cosmic rays are unseen particles that makes a lot of difference. Now, we journey into the hidden connections between cosmic rays, those mysterious travelers from deep space, and life as we know it on Earth. It's a story that stretches from the farthest reaches of the galaxy right down to the air we breathe, the weather we experience, and the very evolution of life itself. Cosmic rays, though invisible and often overlooked, are constantly showering our planet with a stream of high-energy particles. These particles, arriving from distant supernovae or the intense environments around black holes, carry with them the potential to alter our atmosphere and influence the biological processes that support life on Earth. One of the most compelling ways cosmic rays touch our lives is through their interaction with Earth's atmosphere. As they crash into the atmospheric molecules, they can trigger a waterfall of reactions, one of which includes the formation of clouds. This process begins when cosmic rays ionize tiny particles in the atmosphere, creating a nucleus around which water vapor can condense. The result? Clouds. This may sound simple, but the presence or absence of clouds has a profound effect on our climate, affecting everything from daily weather patterns to long-term climate changes. It's a delicate balance, and cosmic rays play a crucial role in maintaining it. Beyond the skies, cosmic rays have a more direct influence on life on Earth. The mutations necessary for the evolution of species can sometimes be stimulated on by these cosmic visitors. When cosmic rays collide with living organisms, they can alter DNA, sometimes leading to mutations. While the idea of mutation may raise images of comic book heroes, in reality, these genetic changes are a natural part of evolution, contributing to the diversity of life over millions of years. This doesn't just highlight the invisible impact of cosmic rays, it invites us to reconsider our place in the universe. It tells a story of interconnectedness, where distant cosmic events can ripple through the cosmos and touch the core of our being, influencing our climate, our environment, and even the evolutionary journey of life on our planet. But our story doesn't end here. As we continue to probe the mysteries of cosmic rays, scientists are uncovering even more ways in which these particles influence our world. From their potential to affect electrical grids and technology, to their use in uncovering the secrets of ancient art and historical artifacts. Through radiocarbon dating, cosmic rays are proving to be a powerful tool in understanding both our world and the wider universe. The exploration into the relationship between cosmic rays and life on Earth reveals a tapestry of connections that is vast and complex. It's a reminder that the universe is not just something out there, distant and detached, but is closely connected to the inner workings of our planet and the evolution of life itself. As we unravel these connections, we not only gain insights into the mechanics of our world, but also develop a deeper appreciation for the amazing universe in which we live. Now let's explore how present-day scientists are trying to understand cosmic rays, showcasing the cutting-edge technology and ambitious experiments scientists are using to unlock their secrets. This journey into the heart of cosmic ray research lights not just how we study these vague particles, but also why their investigation is crucial for advancing our knowledge of the universe. At the front of cosmic ray research are complex detectors and observatories, both on Earth and in the vast expanse of space. These instruments, designed to capture and analyze cosmic rays, are our eyes and ears in the cosmic ocean. Ground-based observatories like the High-Altitude Water Cherenkov Experiment, HALS, in Mexico, use large arrays of water tanks to detect the showers of particles created when cosmic rays hit the Earth's atmosphere. Meanwhile, in the silence of space, satellites such as the Fermi Gamma Ray Space Telescope orbit our planet, capturing high-energy gamma rays, which are closely related to cosmic rays, offering insights into their sources and properties. But studying cosmic rays isn't just about building bigger and better detectors, it's also about understanding their impact on technology and society. For instance, cosmic rays play a significant role in the functioning of our modern technological infrastructure. They can induce errors in electronic systems, from the smartphones in our pockets to the computers aboard aircraft. As our reliance on technology grows, understanding and mitigating these effects becomes increasingly important. Moreover, cosmic ray research has unexpected benefits beyond understanding the cosmos or protecting technology. For example, cosmic rays are used in muon tomography, a technique that allows scientists to peer inside structures, from volcanoes to ancient pyramids, without physically disturbing them. This non-invasive method provides invaluable information in geology, archaeology, and even national security. This exploration into the study of cosmic rays today not only showcases the cleverness and curiosity driving this field, but also highlights the impact of cosmic ray research. It's a story that connects the distant reaches of the universe with the practical challenges and wonders of our daily lives, underscoring the value of scientific exploration and discovery. As we stand on the brink of new discoveries, the study of cosmic rays continues to challenge and expand our understanding of the universe. It's evidence to human curiosity and our relentless pursuit of knowledge, driving us to explore the unseen and unknown, and in doing so, uncover the interconnection of all things cosmic and terrestrial. As we stand on the brink of new discoveries, the future of cosmic ray research holds endless possibilities, promising to unlock even more secrets of the universe. Imagine a tomorrow where cosmic rays help us map the unseen, predict the unpredictable, and answer questions we haven't even thought to ask yet. This is not just a dream. It's the next chapter waiting to be written in our quest to understand the cosmos. In the coming years, we'll see the launch of more advanced observatories, both on Earth and in space, equipped with technology beyond our current imagination. These new instruments will allow us to detect cosmic rays with even greater precision, revealing the intricate details of their journey across the universe and their interactions with other celestial bodies. This will not only deepen our understanding of cosmic rays, but also provide new insights into the very fabric of space and time. Moreover, scientists are developing innovative methods to study cosmic rays, including using the moon as a giant detector. By observing the shadows that cosmic rays cast when they hit the lunar surface, researchers can learn about the particles that don't make it to Earth. This lunar observatory concept could open up new frontiers in cosmic ray research, allowing us to observe ultra-high-energy cosmic rays that are rare or impossible to detect with current technology. The potential benefits of this research extend far beyond the realm of pure science. By better understanding cosmic rays, we can improve our forecasting of space weather events, protecting satellites and communication systems on which our modern world depends. Additionally, insights gained from cosmic ray studies could lead to breakthroughs in materials, science, medical imaging, and even the development of new technologies for energy production and radiation protection. But perhaps the most exciting aspect of the future of cosmic ray research is its ability to bring us closer to answering some of the biggest questions in science. What is the nature of dark matter? Are we alone in the universe? How did the universe begin? And what is its ultimate fate? As we harness the power of cosmic rays, we edge closer to these deep truths, reminding us that we are not merely observers of the cosmos, but active participants in its unfolding story. With technology advancing at an unprecedented pace, we're gearing up to peel back even more layers of the universe's deepest mysteries. Imagine detectors so sensitive they can trace the origins of cosmic rays back to their cosmic cradles, or satellites that can map the sky with such precision. We'll finally unlock the secrets of dark matter and the very fabric of the cosmos. So let's embark on this journey together, with eyes wide open to the wonders that await, ready to be amazed by the universe's endless marvels. And thank you for joining us on this extraordinary adventure through the enigmatic world of cosmic rays. The story doesn't end here, it's just the beginning. Stay curious, keep exploring, and who knows what mysteries will unravel next. The universe is vast, and its secrets are waiting for us. Let's discover them together.